Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at how we find equations of tangent lines and then use those tangent lines to approximate a value. Now in front of you, you're looking at a question, and the question is, air is being pumped into a balloon for 3 seconds, causing the radius r of t, a twice differentiable function measured in inches, to increase at a rate of r prime of t measured in inches per second. Selected values of r of t and r prime of t are given in the table below. Now, in this table, time is our x, r of t is our y, and r prime of t is our inches in inches per second. Now be aware we are going to be using point slope form, which in general is y minus y1 equals m times x minus x1. Now, if we were to translate this, we would have f of t minus, r of t, let's get the variable correct. R of t equals r of c equaling r prime of c times time minus c. There we go. So in this problem, let's assume for the moment I want to find the equation of the tangent line at, let's say 1. Well, according to this information, r of 1 is equal to 5. R prime of 1 is equal to 8, which means that r of t has to be minus 5 equaling 8x minus 1. And you'll notice it's not that bad. Let's take a moment. This was at, there's our equation. This was at t equaling 1. Let's now look at t equaling 2. So if we're looking at t equaling 2, we're now talking about r of 2 is 8, and r prime of 2 is 4. So the equation of the tangent line has to be r of t minus 8 equals 4 times t minus 2. Now we're often asked to approximate values using our tangent lines. This is often referred to as local linearity. So we are going to use local linearity to use our tangent line to get a reasonable approximation of a value. Let's go ahead and find let's do 1.2. Once again, we can use any value. I'm going to use 1.2. And 1.2 is closest to 1 as opposed to 2. So we're going to use our tangent line at 1 to find our approximation. R of 1.2 minus 5 is equal to, let's make sure you can see it, 8 times 1.2 minus 1. Therefore, r of 1.2, and keep in mind this is an approximation, will be approximately 5 plus 8 times 0.2. Now I got the 0.2 by subtracting 1 from 1.2. Simplifying it further, r of 1.2 is approximately 5 plus 1.6, and therefore r of 1.2 will be approximately 6.6, and this is in inches. Let's go ahead and now use our second equation of the tangent line. This time let's find at t is approximately 2.1. So we're going to put it in as r of 2.1 minus 8 is equal to 4 times 2.1 minus 2. We then have r of 2.1 equals 8 plus 4 times 0.1. Or, once again, this is an approximation, r of 2.1 is approximately 8 plus 0.4 And therefore we have our approximation. R of 2.1 is approximately 8.4. And once again, our units are inches. This is how we find the equation of a tangent line and use that equation of the tangent line through local linearity in order for us to find an approximate value. It's not very difficult, but it does take practice. I hope this has helped. If you like this video, please remember to click like. Otherwise, thank you very much. Have a wonderful day. Take care. Be safe. Be kind to each other. Remember, it's easy to be mean, so try to work harder and be nice to each other. Change starts from within, everybody. Bye, Hornets.